Okay, here we are, part 3 of 3. Let's write some assembly language code for the RISC-V. Um, Assemble it, convert it into hex file, load it over the APB bus into SERV RISC-V processor, and watch it twiddle those GPIO pins. So here I am. I wanted to write a program for the RISC-V processor, the SERV processor in this case. And so on the SERV processor, he had in his software folder like 4 files. One of them was blinky.h. Which is just a bunch of 8-digit hex numbers. And this is enough to make the SERV processor do blinky. I was able to load that into a simulator, and from that, I could actually simulate that. And so, oops, not that way. How about this way? Um, I have my scripts compile. So I have a script to compile the Verilog program, the SERV, and the test bench. And then I had a script sim. These are all checked in, so you can get them. So the sim, and boom, and what that does is it runs, and oh, I missed a step. So I've modified it so that you tell it what the file is. In this case, software/blinky.hex. And boom, you can see it where you got this blinky. The least significant bit is toggling. And that's what I started with. In the last video, we boom up this so where instead of just 1 bit out of the RISC, now it's 32 bits out. So what I want to do is make this guy count. So I want him to go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And that will basically be showing that I can modify the assembly language code. And so anyway, it's going back to here. He had a little bit of an answer to how I do it, in that he's got this make file. And in that make file, you can see that he runs GCC, which on the assembly language code, which is the .s file, and that produces an ELF file. And that ELF file you can convert into a bin file, which you can then convert into a hex file with this script. And you can just take a look at this script. This is a script that came right out of the SERV area, and it's pretty straightforward to just convert binary to hex, ASCII hex. He had and I haven't been able to work around it, so I think it's really needed, is this this loader or link file here. Just tells where the sections are. Looks pretty basic, but so anyway, so I worked on, the first thing, it's one of the first things I say, okay, let's copy blinky.h. So save, and then I said, let's see if I can actually recreate it. So I do a make blinky.hex. And boom, let's see. Um, blinky.hex. Great. And then I do a diff of blinky.hex with blinky.hex.save. And look at that, they're identical. That means that I can now compile or assemble a program. Hey, that's great. And so it came out of this make file. And eventually I'll learn more and more about this make file and what it actually does. But for right now, it's a toehold that will get me to the next level and level up. And so now what I want to do is this blinky.s creates, oops, keep going that way, creates this toggling pattern. What I want is an incrementing pattern. So let's see if we can figure out how to do that. So we do a copy of blinky.s to, how about counter.s. And let's take a look at that. Let's edit it. And if you take a look in down here, we got some interesting things. We got this GPIO base. That looks like a decent address that's out somewhere. It's got some sort of start gidgey here. And this is my first day with RISC-V assembly language. So I'm just poking around here. And I'm saying, look at this bad boy. Nice comment. Again, never trust comments. But it says invert LED. And an XOR, it seems like that would do an invert for you. And what I really want to do is this TO seems like some sort of accumulator. I think there's a certain set of registers in the RISC-V. I got to understand that better someday. But it seems like right now it's taking, and this is the destination maybe. This is the source. You take the source, exclusive OR with a 1, that would toggle that LSB bit, and that's what we were seeing. Um, Instead of an exclusive OR, what I want to do is an increment. And so I poked around on the web. I couldn't find increment, but I found that add I. So basically what this would, I think, would do is take this accumulator, add 1 to it, put it back into the very same accumulator, and that should increment just that one change. So let's do a control save. Let's quit out of this. Let's do a make of counter.hex. List-LTR. Oh, look at that. We got a brand new counter.hex file. So take a look at it. We got counter.hex. Wow, looks nice. I wonder how different it is from the diff counter.hex from blinky.hex. I think it's just one line. Yeah, look at that. That's the difference between an exclusive OR and an add. All right, so now let's go back to our simulator. See, it's just 0, 1, 0, 1, 0, 1, 0, 1. All right, let's go in and load into it instead of blinky.h. Counter. What do we call it? Counter? Counter, yeah. Let's see what happens. Oh my goodness. Look at that. It's incrementing. So now we can make our blinky blink with these, like some bits up in here. We can tap into those outside of the SERV environment in the cape. All right. So I think it's there. It's working. It's simulating. So now we want to copy this guy. Let's go back to this guy. Counter.hex to, I do not remember my IP address, but I have it from an old putty session. Right here, 172.16.7. 172.16.0.7. Did I get that right? 172.16.07. Nice. All right, put a colon on the end of it. Put a beagle at the beginning of it. Beagle at. That copy. All right. Tap PWD. And do an LS. Well, we want to do an SSH into the same place. So now we're SSHing into the Beagle board, and counter.hex is over here. It's that simple program. And now sudo /run serve. It's a program we looked at earlier, that we developed earlier in a previous video, which basically loads the memory of the serve processor over the APB bus, so you can dynamically change what the serve is actually doing. And so in this case, $. Oh. And so we're loading this program now into this program, and it's now running. And if you look at the counter LEDs, they are indeed incrementing. So right there, demo, baby, it's done. So now we can modify the assembly language code program, convert it to a hex file, load it over the APB bus into the serve. And now we can make the serve do our bidding as we wish. Nice. So I think that's wraps up this series. So it's just poking around in counter.s, the assembly language program. I found another important optimization. That's is that we had this delay here. And so basically it spins around and it waits between every increment, or it was between every toggle. But we don't want that anymore because we're counting and we want to count as fast as we can. So we've had this little couple of like this little code where it looks like it's incrementing T2, and then when T2 gets to some sort of time value, then when it gets to when T2 gets to this T1, uh, um, then if it I guess if it's not a T1, then it stays in this little loop. Otherwise, it falls down to this one where it jumps back to here. And so that last jump we want to keep. We want to get rid of this one and this one and this one, I think. And so we save that guy. We quit out of that. Make counter.hex again. Okay, we've just done that. And now we should be able to go up to cd dot dot, and we should be able to, uh, let's see, scripts, run. Oops, send. Oops, forgot something. Whoa. And if you remember from the previous episode, we didn't get, so this both run the same amount of time. You can see this guy is just blasting through versus the other one was kind of going through. So this is fast now. So now we want to SC, we're going to go back down to software, SCP, ls, SCP, counter.hex to this location here. All right, so that's copied over to there, and now we should be able to SSH into our Beagle board. And we should be able to uh, it's sudo /run serve counter.hex and run it. Now it's blinking faster. Oh yeah, it's rocking now. So it's blinking much faster. All right, I think that wraps it up. I think that basically the sky's the limit now. We just have to figure out this assembly language and go from there. So that'd be all. This is the SERV RISC-V processor running at 50 megahertz on a polar fire SoC in the FPGA fabric, blinking the LEDs through a counting pattern. Here's the FPGA. This is the Beagle board, the BeagleV Fire board. The SERV program is loaded from over the APB bus.